Welcome to Dr. Sirme YouTube channel. Thank you so much, all my subscribers, to all my students. All the best.
Hello, my good students. This is Dr. Sirme, and what I want to do is to take you through the KCSE 2021 Mathematics Paper 1, a paper that was not well performed. And as we go through the paper together, you'll agree with me, the paper was not that difficult. It required the student to, having practiced more, read and understand the question. So otherwise, what I'll do for this one, we shall do section 1. So this video is basically section 1. Then later on, I will just take you through the section 2. Thank you. Follow with me. So as usual, I'm going to start by posting the question so that the student can attempt the question. Then thereafter, we shall go through the questions together. I'll just be doing them right here. Thank you.
A good paper will always start with a cover page. And there was the cover page, the instructions, they're very, very important. Good. Of course, it's a full paper, 24 questions. 16 questions are short structured, compulsory. Then you choose 5 questions out of the 8. Question 1, a question on fractions. Question 2, question on LCM. Question 3, a question on transformation, especially rotation. Question 4, linear inequalities. Question number 5, this is a question on polygons. Yes, polygons. Question number 6, linear motion. Then question number 7, this is quadratic expressions. Question 8, we're talking about commercial arithmetics, especially commission. Question number 9, this is a vector question. Then question number 10, it's a question on rates. Question number 11, this is a trigonometry 1. Question number 12, geometric construction. Then question number 13, it's a question on time. Question number 14 there, it's a similarity. Question number 15, it's a question on indices. Question number 16, differentiation. Yes. Then section 2, these are just questions. Maybe for this one I'll not do, but you can still go through them. That's question number 17. Question number 18, there it is. Question number 19, question 20, question number 21, question number 22, 23, statistics there, and then 24. Remember, these are 8 questions, long structured, where the student is expected to do just but 5 of them. So kindly stop the video, attempt the questions before going through the answers together with me. Thank you.
This was the first question in this paper, the KCSE 2021, the paper 221/1. With the first question, it was the operation of fractions. And for this case, the question went with 4 marks. With this, you can start with the numerator, the upper part. And in this case, BODMAS applies. BODMAS apply. Brackets of division, multiplication, and addition. So for this one, I'm going to start with of. And that's what exactly I've done. This is, remember this is what I'm doing here. The numerator, 2 over 3 multiplied by 9 over 4. 9 over 4. With this is 2 by 2, 2 by 2, 2 there. That is 4 divided by 2. By 3, 1, by 3, 3. And that's how I get 3 over 2. 3 over 2 here. With that, I'm supposed to divide it. I'm supposed to do 9 over 5 divided by 3 over 2. That is the next operation. After of, I can now do division. With the division, now here I am. I'm supposed to do 9 over 5. Now I do multiply by 2 over 3. 2 over 3. By this, 3, 1 by 3, 3. This will be 6 over 5, 6 over 5. And here it is, 6 over 5. And now I can do subtraction. I subtract 3 over 10. So with that, I need an LCM 10. The LCM 10 divided by 5, I get 2. 2 times 6, 12. 12, there it is. And then I do 10 divided by 10, this is 1 times 3. That is 3. I do subtraction, that is where, that is an M1. Then you go to the denominator. The denominator have an operation here, addition, and I also have multiplication. Again, going by BODMAS, I can start with multiplication. That is with multiplication, I'll do this first. So with that, 22 over 39 multiplied by 13. Remember this, now I can do it in proper fraction. 1, 13 over 11. By 13, 1. By 13, 3. By 11, 1. By 11, 2. That's how I get 2 over 3. 2 over 3 here. Then I'll do 5 over 6. I do add the 2 over 3. By that again, LCM. The LCM is 6. 6 divided by 6, 1. So this is 5. Then this will be 2, 4. And that's how I get 9 over 6. Remember, the equivalent fraction is 3 over 2. So either of these. And that's where the student scores the next method mark. Now, if a student now is able to attempt to divide the numerator by the denominator, again, the student is able to score the third mark. And finally, if now I can do 9 over 10 divided by 3 over 2. I do reciprocate this one, 2 over 3 now. I do cancel by 3, 1, by 3, 3, by 2, 1, by 2, 5. And I end up with 3 over 5. That's where the student scores the final answer mark. Otherwise, if the student is able to write it in decimal, still that is correct for the 4 marks. Question number 2, a question on LCM. Question derived from Form 1 syllabus. You're given that there are 2 bells, that these bells are going at an interval of 35, the other one goes at an interval of 42 minutes. So the very first thing you do is to work out the LCM of the 2 numbers. You can decide to use the factor methods that like I've done here. You can use the table method or any other method that is appropriate. So with this, the LCM, you go for the factors, just the single factor with the highest power. Like there is a 2, there is a 3. Yes, I can take a 5 and a 7. So if I do that, actually if I can, the student has the M mark. Otherwise, it is 210 minutes. Now, you're told that these 2 bells went together at 8:48 a.m. This is the time the bell went together, or rather simultaneously. Then you're supposed to determine the next time these bells will go together again. So what you do, take the minutes, the LCM, convert it to hours, or rather to hours and minutes. 210 minutes is equivalent to 3 hours and 13 minutes. So that is all you need to add. I am attempting here to add another 1 mark. The time these 2 balls will go together again will be 12:18 p.m. Now for the final marks. Those are 3 marks. I believe such a question is not difficult for a Form 4 students. Question number 3. Question number 3, the student was given this figure. And the question was, the student is expected to complete this figure and show the rotational symmetry of order 3. So with that, if the rotational symmetry is of order 3, it means for a complete rotation, that is a complete 1 turn, there is order 3. So that means the angle thereabout will be 120. So what exactly is the student expected to do? at point 0, because that is at point 0, the student is expected to measure an angle of 120. 120. Yes. Then determine the length from this point to this point using a pair of compass. The angle, of course, the student is expected to measure with a protractor. Then determine this end, and then, of course, mark it there. Try as much as possible, because this should be with the scale drawing. Then determine the size of that other rectangle there, and then plot it there, draw it there. And of course, note the side at which that rectangle is. Then the student again is expected to measure an angle of 120. The very same thing, measure from this point to this point, mark it, then draw the other rectangle here. And of course, this angle will be 120. So how was the student to score for this question? If there was the 120 degrees, the student scores the B1 there. And of course, the first arm here, another B1, and of course, another B1. 3 marks. Number 3 on rotation or other transformation. A bit tricky, but not very difficult. Question 4, a question on linear inequality, form 2 work. You are supposed to evaluate and of course give the integral values for the values of x. So here is the compound inequality. So what the student is expected to do, you can first of all consider the inequality up to that point. And what I'm doing, I've tried to do here is just to put the like terms together, the x together, the variables without, or the constants without x together. And for that, you can consider this part, then it crosses over to be positive. So it is 2x minus 2/3 x. Then of course you have 5/3, then, and this goes with 1. So here it is minus 1. Then you just do simple operation here. That is 5/3 minus 1. You get 2/3. On the other side, you have 2x, subtract 2/3x. You get 4/3x. So at that point, remember what you do, you are eliminating the 4/3 here. So multiply both sides by 3/4. So this one, the 4/3 will disappear. You'll have x. On this other side, you'll have, this is 2, this is 1. So you'll have 1/2. And that's how we are ending up with this. And this is where the student scores the first bonus point. With that, now the student can consider the inequality from this point. And when you do that, the very same thing I've done here, the x on one side. So in this case, the x will be on my left hand side. So with that, it will be positive x, yes, positive x, subtract 2/3 x. Then on the other side, it will be 2 subtract 1. So it will be 1. Then on this other side, it will be 1/3. To eliminate these 3, I can multiply here by 3, here by 3. So this will go. This will be x is less or equal to 3. With that, I can join the two inequalities, the simple inequalities I had, and this is what I'll end up with. Remember, at this point, the student scores the second bonus point. Having considered this, remember what exactly is happening. That the values of x, if this is my number line, this is 0, 1, 2, maybe 3, 4, and this is -1, -2. Well, with that, the values of x starts from a point, a half, somewhere a half, of which a half is not even included, and goes all the way to +3, and +3 is included. So if you are to consider the integral, get that word from the word integers. These are whole numbers, okay? So we consider 1, 2, and 3. These 3 values, which gives us our final answer, or we can even call it the bonus 1, or just the answer 1, these are the integral values, the whole numbers between these two extremes. Remember, 3 is included. If a student is to write 3, 2, 1, the order does not matter. And that was question number 4. Question number 5, you're given an irregular polygon. What you're given is that 2 of the interior angles are 90 degrees each. You're also told that the rest of the angles 150 each, or degrees each. With that, the question is you find the number of sides. What we know is this formula. This formula is the sum of all interior angles. 2n minus 4 into bracket 90. With that, I can just have the formula. Then I equate to the 2 angles, 2 times 90 plus 150 multiplied by the remaining angles. Remember our assumption in this case, n is the number of sides. N is the number of sides. So if 2 angles are 90 each, the remaining angles, it is n minus, or they are n minus 2, the 2 angles that we have already considered. So with that, it is 150 multiplied by the remaining angles, because each is 150. By forming that equation, the student scores the first method mark. So having the equation, now we can solve the equation. Open the brackets, then put the like terms together, just like I have done. If the student is able to follow, maybe to a point here, then almost to the end, the student scores another method mark. And finally, the answer is as simple as that, 3 marks. Question number 6 is about 2 athletes, Kipsang and Mutunga. And I've tried to draw for you the scenario in this track. You're given that Kipsang is 310 meters from the finish line. Behind him is another athlete, 50 meters behind, that is Mutunga. And that is the first scenario. To the end, or as this race comes to an end, Mutunga is at the finish line. Kipsang is 10 meters behind. What we know is the speed for Kipsang. Kipsang is running at an average speed of 5 meters per second. So the question is, we find Mutunga's speed. We find the Mutunga's speed. There are several ways you can approach this. Maybe the first way to argue this. Look at Mutunga. Mutunga has ran 50 plus 310. So the distance that Mutunga has ran is 50 plus 310. That is 360 meters. 360 meters. At the same time, Kipsang has ran a distance of 300 minus 10, because he is not yet to the finish line. So 310 minus 10, it is 300. The time that Mutunga has taken to run from the point here to the finish line is the same time Kipsang has ran from this point to 10 meters to the finish line. So what do I argue? Remember, time is distance over speed. So how am I going to argue this? I'm going to argue that 360, that is the for Mutunga, divided by x, I don't know his speed, is the equivalent to 300 meters ran by Kipsang divided by his speed, 5 meters per second. Then you solve for x. You solve for x comfortably. Remember, that will be x will be given by 5 multiplied by 360 divided by 300. If you're able to work this out with your calculator, then this will be 6. So the speed for Kipsang, not Kipsang but Mutunga for this case, is 6 meters per second. The scoring here if you are able to relate this, you can get a bonus on a method 1. Then the operation there maybe method, then the answer 1. What you can start by, you can go direct. You can argue with Kipsang. Kipsang ran 300 meters at a speed of 5 meters per second. So by that you can work out the time. If that is the case, you can go direct working out the time. That Kipsang ran for 300 meters at 5. So taken is 60 minutes. You working out the speed for Mutunga. Mutunga ran 50 plus 310. Mutunga ran 360. So 360 divided by 60. Again, you get 60 meters per second. So that question was that short and simple. If of course the student had studied the topic, that is a linear motion. Question number 7, the student was expected to simplify. The student was to simplify the what we call the quadratic expression here. So like what we given here, this one we can apply what we call the quadratic identity to expand this part. So this is 16, that is 4 squared, then 4 times 2y, that is 8y times 2, 16y. Then I do square the 2y squared, I get 4y squared. Then this is the point where maybe the catch was because of this bracket and the negative there. First of all, we can expand. We can just expand what is in bracket here using again the quadratic identity. 4y squared, that is 2y squared, that is 4y squared, that is. Then I have 2y multiplied by 4, negative 4. I get negative 16y. Then finally I'll have 34 squared. I get 16. Remember those quadratic identity. If I'm given ab squared, this will give me a squared, then 2ab, then b squared. I think in one of my videos I have shown you how to do this. If it is like this one with subtraction, then it will be a squared minus, now this one will be minus ab, then b squared. That is it. So with that, now we can open the brackets. We can open this bracket. So having said that, this one will remain as it was here. Then minus 4y squared, negative times negative, I get a positive here. Then to be positive 16y, then minus 16. Because of this negative, positive, I get negative there. So what I have, the first question now in method 1 is for putting the like terms together. Like 16 minus 16, that is 0. Then I have 4y squared minus 4y squared, that disappears. Then finally I'll have 16y added to 16y. I get 32y. And that is how the student scores the 2 marks. Question number 8, a question on commission. That's under commercial athletics, Form 1 work. You're told that the commission given for a sale of a table is 8% of the cost of the table. Then the commission for the chair is 5% of the cost. The cost of a chair is 2,000. The cost of a table is 4,500. Okay, you're told that in this salesperson sold 3 tables less than the chair. So if the chairs are represented by X, then the tables will be represented by X minus 3. So with that, for in a certain week, the salesperson earned 3,980 shillings. So the question is, you determine the number of chairs that this person got or sold. We start by working out the commission for each chair sold. 8% of 4,500. You get that. The commission for the table, or for the chair, that will be 100. 5% of 2,000. If the student was able to work out the 2 commission, 1 point or 1 mark there for the method, then forming the equation. 100 times x, the number of chairs sold, added to 360 multiplied by the number of tables that this salesperson sold. That is as I have formed, equals to the total sale. By forming that equation, another method one. If the student is able to put the like terms together, then go ahead to solving for the values of x to get the answer 11, and the final mark for the third mark for the number 8. Question 9. This one was a question on translation vector. And for this one, you're given that a point A, negative 6, 2, is mapped to A prime, that is 3, 5. So this is something you should know. And one of my friends in this platform of YouTube called Mwalimu Hassan told me OT. Object added to a translating factor, you get the image. OT. If you know OT, any OT, you have it. Object is added to translation, you get the image. So that is all we need to do. And now in this case, we let our translating factor to be AB, to have the coordinates AB. With that, I have negative 6, 2 added to AB, I'll get 3, 5. So what I need to do, the positive coordinates here, or vector, I take it to the other side. Then I'll have 3, 5, subtract negative 6, 2. With that, this will be 3 minus negative 6, you get 9. Then 5 minus 2, you get 3. So the T I'm looking for, and that is the answer there, is 9, 3. So I have the answer for part A. Part B, been given the image of a certain point P. If that is the case, I can now use the same OT here. And now I'll know O will be given by image, that is the object, is given by the image, subtract the translating factor. That is all I'm going to do. I have the image, I subtract the translation factor there. That is negative 4 minus minus 9, I'll get negative 13. Then 2, negative 3, I'll get negative 1. Then I put them in the coordinate form. By that, if I'm able to give that format, 1 point, then the answer 1. That is question number 9 done. Question number 10, you have two guys here. You have John and Jane. You're given that these two guys are having vehicles, and they're using their vehicles to travel from point one to another. With John, his vehicle consumes 1 liter for every 12 kilometers, and he uses 2,805 shillings to travel from A to B. You're given that Jane used 12.5 liters to travel 100 km. So the question is, you find the cost of that Jane will incur in terms of fuel to travel from point A to B, as John did here. So there are several ways you can do this. But what I can encourage my student is take the real life situation. Take this as a real life situation, and that way you'll be able to interpret the question. You'll be able to interpret the question. If I can consider method 1, the first method here, as simple and direct. John uses, for every 12 kilometers, he uses 1 liter. In total, John used 2,805 shillings. What about Jane? This is the case for Jane. His vehicle is consuming 1 liter for every 8 kilometers. How did I get 8 kilometers? It is 100 kilometers. I divide by 12.5, because I'm given that Jane traveled 100 kilometers using 12.5 liters. So with that, I'll get 8. I'm going to interpret this. If this vehicle for John is using 1 liter for every 12 kilometers, no, it's a bit economical. So this person used 2,805. What if I have another vehicle that is consuming 1 liter for every 8 kilometers. That vehicle is not very economical. So the cost here, I expect it to be a bit high. So with that, I'm going to increase. So this is, I multiply by 12 over 8. The ratio now is increasing. If I increase that, I'll get that. And that is my final answer. So if the student is able to get that rate of consumption here, 1, then the method here, 1, and the answer 1. Otherwise, the student can still work out the distance from A to B using the case scenario for John. And how will that be? It is the amount of money this person spent divided by the cost of fuel, that is the cost of fuel per liter, then multiplied by 12 kilometers, the kilometers traveled. That is 306 km. So 306, that's the distance from A to B. Then I divide by 100, that is I divide by the kilometers divided by kilometers to know how many kilometers did I travel. Then multiply by the liters there. Of course, times the cost of 1 liter of fuel. I'll get the same. My answer, 4,207.50 cents. Question number 11. The question was, the student was expected to solve for the value of theta. And you're given that the sine of 2 theta minus 15 is equivalent to or equal to cos of 3 theta. So the student was supposed to recall that anytime you have the sine and cosine equated directly, this one we're talking about complementary. They're called complementary angles. The two angles, these angles and these are complementary. And what do you understand by complementary? The angles adds up to 90 degrees. For example, if you think the sine of an angle like 20, it is automatically equal to the cos of 70. And any other angle, even the sine of, for example, 15, it is equivalent to like the cosine of an angle like 75. 75 plus 15 is 90. So with that, the student was expected to take this angle, add to this angle, then equate to 90. As simple as that. So 2 theta minus 15 plus 3 theta equivalent to 90. Then you solve for theta. The theta together, that is 5 theta, minus 15 is 90. On this side, you can add 15 on both sides. Remember, it was minus 15. So you can add 15, that will be 0. You add 15 on this side. So 5 theta is 105 degrees. And with that, then finally, you have now the division. By 5, 1, by 5, 1, by 5, 1, then by 5, 21. So with that, the value of theta is 21. Maybe you ask yourself, how was the student to score the marks? For the method, for the formation of the equation, method 1, then the second mark was for the answer. Question number 12. This is a question on construction. And what exactly is required of the student? The student is supposed to do the construction, and the student is restricted to use a ruler and a pair of compass only. A ruler and a pair of compass only. So the student is supposed to construct a trapezium ABCD. A trapezium ABCD. And this is how a sketch will look like. Already the student has been given the line AB, which is 8 centimeters. Then the student is to construct the trapezium such that the angle BAD here is 67.5. 67.5. The line AD is 5 centimeters. And of course, remember now the DC and AB are parallel. Then the student is given that the line BC is 5.5 centimeters. So what exactly I'm going to do is to guide you. Then using your ruler and your pair of compass, you can go with me. You can go with me. Now, we start by constructing an angle of 67.5. There are several ways the student can do that. If I can extend this, I can decide to draw a perpendicular line on these points. Remember, for me to draw a perpendicular line, I need to stand at A, make an arc, the same radius. I extend the pair of compass, I stand at this point, I make an arc. I can even do another one at the bottom, no big deal. Using the same radius, I stand here, I make an arc, and I do another arc here. This one, it's 90 degrees. Remember now, this is just a guide. So follow as I do. This is 90 degrees. So what exactly do I need to do? I need to bisect this side from my left hand side. So what I can do, I can make an arc and an arc. Then standing at this point, I make an arc. Here, I make an arc. So this one, I have just bisected. So this angle is 45 degrees. So what does that mean? The whole of this angle is 135 degrees. So if I want to get an angle of 67.5, I need to bisect this. So again, I can now stand at this point, make an arc, Standing at this, I make another arc. Standing at this point, the same radius, an arc. I hope I'm not too fast. Student can be able to follow. So then I join. Remember, this is just a sketch. If I do that, this angle here is 67.5 degrees. Therefore, I have the first B mark, the angle 67. Then I'm supposed to measure using my pair of compass and the ruler. I measure 5 centimeters, and standing at this point, I mark 5 centimeters. I have been able to locate point D for another B mark. I've been able to get that B mark there. Then, with that, I'm supposed to draw a parallel line. That is another parallel line to AB. So how should the student do that? I can stand at point A. I measure the 5. I do the same here. I measure 5. Then I just put a mark. 5 centimeters. Standing at B, 5 centimeters. Then I measure from A to B, 8 centimeters. I stand at this point, I make an arc. What I'm trying to do is just to construct something that looks like a parallelogram, so that this line and this one will be the same. If I can repeat what exactly I've done, I've measured with my pair of compass AD, 5 centimeters. Standing at B, I make an arc. Then I measure AB, 8 centimeters. Standing at D, I mark it. So the line I will draw there, if I can join this point, this line and this one are very parallel. Okay? Good. We proceed. We have the third B mark for the parallel line. Then we need to locate point C. And you're given that AC is 5.5 centimeters. So with your pair of compass 5.5 centimeters, stand at B, make the arc. The question has guided you that the angle ABC is acute. So we are going to disregard this, and then we join this. So this 5.5 centimeters, and this is point C. Well, with your pair of compass and a ruler, you can be able to follow what exactly I've done. And finally, I have the trapezium ABCD. If the student is able to locate point C, another point for the 4 mark. So kindly construct it during your free time. Thank you. With part B, the students measure DC. With an accurately drawn diagram, that one will give you 3.1 centimeter. Remember, you can be given an allowance plus or minus 0.1. So if it's a 3.0, correct. 3.1 centimeters, correct. Or even 3.2. Just that range. Number 13. With number 13, you're given that there's a guy called Ali. Ali left Mombasa, and the intention was to get to Nairobi. And he left Mombasa on Tuesday at 2:30 a.m. very early in the morning. And it took him 3 hours 12 minutes to arrive to another town called Mutito and A. And then he stayed there for 36 hours. 36 hours at Mutito and A. Then he departed from Mutito and A after now the 36 hours. The journey from Mutito and A to Nairobi, it took 5 hours, 25 minutes. 5 hours, 25 minutes. Now the question is, you determine the arrival time, that is to Nairobi, in 12 hours clock system. The question is very easy. Very easy. Follow with me. This guy started at 2:30 a.m. on Tuesday, then traveled for 3 hours 12 minutes. So if you do the addition, it will be 5:42 a.m. on the same day, Tuesday. So, and actually that's where the student scores the first mark, just the addition of that time. Now the guy stayed in Mutito and A for 36 hours. That is 1 day, 12 minutes. Because 1 day is basically 24 hours. So it's 1 day and 12 minutes. So what do you need to do? First of all, for easy working, you can convert the 5:42 a.m. time to 24-hour clock system. It is 05:42 hours. With that, now I can add. I add 1 day. Yeah, I was on Tuesday, now I'll be on Wednesday after a whole day. We have 5:42 hours on Wednesday. Yeah, that is sometimes very early in the morning on Wednesday. Then you add 12 hours. We will be talking of 17:42 hours on Wednesday. So this is the time this guy left Mutito and A. So this is the departure time from Mutito and A. Then what do you need to do? As my student, you just need to add the time taken for this guy to travel from Mutito and A. You add 5 hours 25 minutes time taken to travel to Nairobi city. So with that, if I do the addition, I will get, and remember now with addition, the student was able to score the second method mark. With that, if I have the departure time, or rather the time, the arrival time in 24-hour clock system, the question was, we get the hour in 12-hour clock system. So with that, I just need to subtract 12. I just do subtract 12, and I'll get 11:07 p.m. on Wednesday. 11:07 p.m. on Wednesday, and that's where the student scores the final answer mark. That is question number 13. Okay, for question number 14, you have a cone. You have a cone, then a frustrum is chopped off this cone. The instruction there is that the volume of the frustrum that has been extracted is 1/8 the volume of the cone. So whatever we have removed volume wise, it is 1/8 of the entire cone. So what we have, we can compare the bigger cone I have and the cone that has been extracted. So with that, I can work out what we call the volume scale factor. Remember, this is 1/8. Then the remaining is 7/8. 7/8. Therefore, the volume of the smaller cone, 7/8, is to the volume of the entire cone. Remember, this is now the 7/8. So with that, I'm comparing the volume. So this is what we call the volume scale factor. 7:8. 7:8. If I compare the smaller cone that I've extracted compared to the original cone that was that we extracted the frustrum. So with that, the student can go ahead and work out the linear scale factor. Remember, linear scale factor is basically the cube root of the volume scale factor. So with that, if the student is able to work out that, that is where the first score was. If the student is able to determine cube root of 7/2 to be the linear scale factor for that, for the two similar objects, they are cones. Good. If we go ahead, now we need to compare. I have represented the height of the frustrum with a H, the height, because that is a question. This is a question. What is the height of the frustrum? With that, I'm able now to do comparison here. We have the height of the smaller cone from here to here. Remember, it is 12. The height of the frustrum was originally 12. Subtract the height of the cone. So the 12 minus h over 12, that is over the original, that is the smaller over the larger one, then is equivalent to the smaller root of 7, cube root of 7 over 2. If the student is able to equate that, then 1 mark there for method. So the only thing remaining is to work out. We solve for h. We solve for h. Cross multiply, remember that. This is 24 to minus 2h or negative 2h equals to 12 root 7. 12 cube root of 7, that is. With that, you can put the like terms together, the h, 2h on this side. Then you have this. If you continue working out using your calculator, you can be able to evaluate this. Then you get 1.044. Divide by 2 on both sides. Then the h, that is the height of the frustrum, is 0.522 centimeters. And that's where the student now scores the final answer marks. Thank you. That's number 14. Well done. Okay, this is question number 15. Question number 15. This is a question on indices, operation of indices. And with operation of indices, you're supposed to solve for x. You're solving for x. And if that's the case, we have our equation there. 8 raised to power x plus 1 minus 2, 3x minus 1 equals to 120. So with that, you can express 8. Remember, 8 is basically by 8. This is by 2, 4, by 2, 2, and by 2 again 1. So 8 equivalent to 2 raised to power 3. That is basically what I've done here. Remember, the x plus 1 is there. So I only need to open the bracket. The rest of the working remains as it is. So I open the bracket here. Then it will be 2 raised to power 3x plus 3. Minus 2, 3 raised to power 3 minus 1 equals to 120. So I have not interfered with my right hand side. If that is the case, now over here I can do separation. And actually this is where now the student scores the first method mark. Look at this. We are talking about 2 raised to power 3 plus 3x plus 3. So if for instance I have like a 2 raised to power 3 times 2 raised to power 2. If I'm operating these indices, the law states that I add the power. So I just add the power. Now I can do the opposite. It was 3x plus 3. So I can separate them. So with this, if it's addition for indices, it means the numbers are being multiplied. And this is what I've done here, just to separate them. This will be 2 raised to power 3x times, the bracket means times, 2 raised to power 3 minus, as it was before, remember there is a minus 1 there. Although with this, I have just tried to separate. Even this one, it was minus 1. Minus of indices means divide. So that's why I've divided by 2 raised to power 1. So with that, 2 raised to power 3 is 8. Then this 2 raised to power 3x remains on its own. Then this is just a half. This is 1 over 2. A half, that is 2 raised to power 3x there equals to 120. Having done that, I can now represent this. I can represent it with m. So then I factor it out. I factor out this because it's common. 2 raised to power 3x is common. I factor it out. So once I factor it out like that, I'll have 8 minus a half equals to 120. So this is a number I can operate, and it is 15 over 2. So 15 over 2 is a number on its own. Then I have outside the bracket 2 raised to power 3 equals to 120. At that point, yes, at that point, that is where now the student can score another method 1. So having done that, now I can multiply this side by 2 over 15. Yes, I multiply by 2 over 15. On this side by 2 over 15. Having done that, then I'll remain with 16. So that is 2 raised to power 3x is 16. So this one, 16 is equivalent to 2 raised to power 4. There. If the student is able to equate now the powers, if the bases are the same, equate the powers. With that, the student scores the third mark. And finally, for evaluating dividing by 3, divide by 3, the student scores the final answer mark. Question number 16, you've been given this function. You've given that function. And Part A of the question is for the student to determine the gradient function. The gradient function is the first derivative, the dy dx. I know to most students the terminology themselves are not very friendly. The first derivative. And how do you get that first derivative? The change in y over change in x, dy dx. Take the power times the coefficient, like in this case 3 times 2, 6. Then the power reduces by 1 when you're doing differentiation. So that one I'll get 6x squared. The second case, the same. 2 multiplied by 3, you get 6. Then the power reduces by 1. So that's how you get the second one. The negative remains. With this one, the power is 1. So 1 times negative 12, you get negative 12. Then the power reduces by 1. The power reduces by 1, that is 0. X raised to power 0, it's 1. So with that, you remain that. So, and that is how you get that mark. That is the gradient function. Well done. Part B of the question, the student is supposed to work out the equation of a normal at a given point 1, negative 1 of that function. Remember, a normal is just a perpendicular line at that given point. So it's just a perpendicular line of a given point. So the way to go about this, we need to remember that what I have here, it is the equation or the function for the gradient, or what we call the gradient function. Therefore, if I want to determine the gradient of any point or the gradient of the curve at any point, I can substitute the values of x in these points and I'll have it. And that's what I'm doing with my value of x here. Remember, this is the value of x. I substitute it in the gradient function for me to determine the gradient of the curve at this point. So by doing that, my x here is 1. So 1 and 1. If I substitute, I will end up with a 6 minus 6 minus 12. If that is the case, the gradient is negative 12. With that, I need to remember, if I'm talking about a perpendicular line to the curve, remember it's where the curve is. If this is the point, and that is the gradient of the tangent that we have now. We have the gradient of the tangent. Now this is the normal. The perpendicular line to this is what we call the normal. That's the normal. So with that, I have the gradient of one line, the tangent. I can find the normal by considering that the product of the gradients of two perpendicular lines is always equal to negative 1. So I have the first gradient times the second gradient that I don't have equals to 1. By doing that, the second gradient of a line is given by change in y over change in x. I will have y minus 1, the 1 for y, it's plus. Then x minus 1 equals to the gradient. By doing this, the student now scores the first method mark. What follows is just making y the subject. And once the student is able to make the y the subject, yes, you end up with that equation, and that's where the student scores the final answer mark. And that is the equation of the normal at a point 1, negative 1 of that curve. Good, and that is the very last question of section 1 of this paper, KCSE 2021 Mathematics Paper 1. Next, I'll be doing section 2. And to all my followers, all my subscribers, all those who watches the Dr. Sirme, the chemistry master YouTube channel, thank you so much. Do not forget to recommend this to high school students, because the content I do upload here, they are very, very relevant to what we cover in high school. Remember, like the 844, before we usher in the CBC, the 844 is here for the next 5 years. I know that is up to 2027. So the contents are very, very relevant. Thank you.
Kindly do not forget to subscribe and even recommend to other students. Do not forget also to check some good work done by other teachers. For instance, you have the Safina High School. you have Mwalimu Hassan, who has done the very same questions I've done. So you can as well check. I have attached the link for his channel. Thank you, and thank you so much.